Okay, hello everybody and I have no idea what day it will be when you watch this. It's Sunday when I'm making this video, so happy Sunday or whatever other day it may be for you. We are going to continue to talk about section 2 today. So we are going to today talk about coterminal and reference angles. Okay, so let's start with coterminal angles. Okay, so what are coterminal angles? When they're in standard position, remember we talked about standard position earlier, and we said that two things have to be true for an angle, or for angles to be, an angle to be in standard position, right? One is that the vertex has to be at the origin, and the second is that the initial side of the angle has to be on the positive x-axis. Okay, so coterminal angles have the same terminal side when they are in standard position. Okay, so they have the same terminal side when they're in standard position. So let's think of an angle in standard position. And again, we're always talking about angles in standard position for our purposes, right? So let's say that I gave you an angle with a measure of, let's just make our life easy. Let's say it's 40 degrees. So if it's in standard position, remember that we're starting on the positive x-axis, right? The vertex of our angle is going to be here at the origin. And since it's a positive 40 degrees that we're talking about, we know that we're going to rotate in which direction, clockwise or counterclockwise? Yes, you are correct. We are going to rotate counterclockwise so that this angle is 40 degrees, right? And again, remember we're using that arrow to show which direction we're moving in because that direction is important, right? Okay, so this angle has a measure of 40 degrees, right? All right, in order for the angles to be coterminal, they have to have the same terminal side, which means that I should be able to find another angle, right, that has the same initial side because it's in standard position and also has the same terminal side. So can you think of an angle that's going to start in the same place and still end up in this same place, but not be that angle of 40 degrees? Okay, so is there more than one? How many are there? What are they? So can you think of at least one? So one possibility, remember we said the direction is important, right? So one possibility is I could start here in standard position and I could rotate clockwise instead and then still end up there. So my angle could actually be this angle. So now hopefully you can really see why that arrow is important, right? Because there's a big difference between the blue angle that we drew first and the pink one that I just drew. What would be the measure of this angle? Well, we know one full rotation, if I started here on the positive x-axis and rotated all the way around and ended on the positive x-axis, would be a full rotation, right? So 360 degrees. We're 360 degrees short, or sorry, no, we're not. We're 40 degrees short of that 360, which would mean that pink angle would be 360 minus 40, or just 320 degrees. Okay, so we could say that 40 and 320, 40 degrees and 320 degrees are coterminal angles. Is that the only angle that's coterminal to 40? So is 320 degrees the only angle that's coterminal to 40 degrees? Hopefully you are shouting, no, of course not. There are lots of them, right? Because we could do what? We could just keep rotating and in either direction. So I could make a full rotation plus that 40. So I could have a coterminal angle that is 360 plus 40 degrees, which is 400 degrees, right? I could also rotate in the opposite direction, right? So I could start here and rotate in a negative direction all the way around. This is going to get really messy, isn't it? And then stop here. So we know that angle would have to be negative, right? One full rotation would be 360. And then to get all the way up to there again, we would do what? So what would that angle in brown be? It would be 360 and 320, right? If we add those together. And then it would have to be negative because it's because we're rotating clockwise, right? So 360 and 320 would give us what? 680 degrees, but then again, negative. Okay, so there are an infinite number of angles that would be coterminal to 40, right? Depending on how many revolutions you made and in which direction you made them. So can we summarize that and maybe write a little formula-ish for that? So we could say that a coterminal angle, if we started with our angle 40 degrees, let's call that theta. What did we do to that in order to get our other angles? And I think it's easier from the pink and the green ones to see what we actually did. So in order to get the green, so if we're going in a positive direction, we did what? We added 360. What if we wanted to go again in that same direction? We would add another 360, right? So every time we're just adding a multiple of 360. So we could have, for example, theta plus 360 degrees times n, right? And then n, what does n actually represent? Well, n tells us both the number of revolutions that we're making and the direction of those revolutions, right? So it's the number of rotations and the direction. If n is positive, then that means we're rotating counterclockwise. If n is negative, we're doing our rotations clockwise, okay? A lot of times you'll be asked for one positive, one negative coterminal angle. And you can give whichever one you want. You can add 360 times, you could make n 100 if you really wanted to, or you can make n negative 22. It makes no difference. So there's an infinite number of possibilities. You could all have different answers, and that doesn't necessarily mean that they're wrong, okay? Let's suppose that our angle was in radians, though. So how would our formula look different if our angle was in radians? And again, remember, we're fighting the urge to convert everything from radians to degrees. If the original problem is given to you in radians, then you want to give your answer in radians. And you don't want to convert from radians to degrees and then convert from degrees to radians again. So you've really got to get your brain to think in radians. All right, so what's the only difference then if we wanted to give our angle in radians? Well, we're still going to start with our angle theta, and we're still going to add some multiple of n. But what is the radian equivalent of 360 degrees? 2 pi. Okay, so same idea. Let's just do one with radians in there because I know how much you love radians. Let's say that we had a reference angle, or sorry, not a reference angle. Let's just say that our angle was 2 pi over 3. And we wanted to find a positive and a negative coterminal angle to 2 pi over 3. Okay, so do you need to visualize it in order to find the coterminal angles? No, not really. You could just plug stuff into the formula, right? But, you know, I hate that. So let's just think about where 2 pi over 3 is. So in which quadrant does 2 pi over 3 terminate? So we know it's positive, right? So we're rotating counterclockwise. And 2/3 is less than pi. So it's going to have to terminate somewhere here in the second quadrant, right? So this angle is 2 pi over 3. Okay? So can you think of one angle that's coterminal to that? So easiest one, well, maybe it's not the easiest to you. One of them would be rotating clockwise instead. So instead of having a positive angle, that could be a negative. And negative, what would that angle be? So this is just 2 pi over 3 short of a full rotation. What is a full rotation is 2 pi, right? And 2 pi is really 6 pi over 3, right? So we're really just doing 2 pi over 3 minus 6 pi over 3, which is negative 4 pi over 3. So that would be one possibility. The other possibility, if we wanted to have a positive angle, would be to go something like this. If we just did one extra revolution, so then we would be adding that one rotation, and that would give us 8 pi over 3. Okay, and again, lots of possibilities, right? I could continue to add 2 pi over 3 to this, or sorry, 2 pi, 2 pi over, continue adding 2 pi to this, or continue subtracting 2 pi from this if you wanted to get a different answer, okay? Okay, so that's coterminal angles. Now we're going to talk about reference angles. And reference angles are super, super, super important because they're going to allow us to do pretty much everything else that we're going to do in this chapter. Okay, so what is a reference angle? Try and use neater handwriting here this time for you. Okay, so the reference angle of an angle in standard position, right? Angles are always in standard position. All right, two things have to be true for us to be able to define the reference angle. So the reference angle of an angle in standard position is the acute angle formed by the terminal side, and it sounds way more complicated than it is, I promise, by the terminal side of that original angle. I'm too lazy, so much for my neat handwriting. And the horizontal axis. Okay, so let's translate that to English for ourselves. All right, so let's say that we have an angle, let's just make our angle somewhere over here. Let's say that this is our angle theta. All right, so let's just think about where the actual reference angle is itself based on the definition, and then we'll talk about how we can find the measure. Okay, so based on our definition, we know that the reference angle is going to be the acute angle. So acute means it has to be what? Okay, you are correct because you're all again shouting. It is an angle that has a measure less than 90 degrees, right? So between 0 and 90. So it has to be the acute angle formed by the terminal side of our original angle. So by the terminal side of our angle theta and the horizontal axis. Okay, so where's the terminal side? Let's start with that. So we know this is the initial side, right? Since it's an angle in standard position and we rotate it in this direction. Where that angle stops is our terminal side, right? So this is the terminal side of our angle. And then we need the horizontal axis. So the question then is, do we want the right side of the horizontal axis, so the positive side, or do we want the negative? And how do we know? So in this case, we definitely want the negative. And the reason we want the negative is because we know that our angle has to be acute. If we choose this side of the x-axis, then we're going to have an angle that is obtuse, and that can't be a reference angle. So this green angle here is, in fact, our reference angle. Okay? Okay, let me draw one more, and then we'll do an example with some numbers. Let's say this time my angle is going to be, let's say this is my angle theta. So again, that lovely shade of brown. And my reference angle is going to be formed with the terminal side. So here's my terminal side. And then which side of the x-axis do I want, positive or negative? Again, we're choosing the side that will give us the acute angle. So in this case, we would want the right side. So that would be our reference angle. Okay, so let's do an example that actually has some numbers. I'm going to get rid of this so we have some more space. All right. Let's say that our angle is, let's start with radians because radians are our favorites. Let's try 6 pi over 11, and we want to find the reference angle for 6 pi over 11. So some of you are automatically going to ignore what I'm saying and you're going to try and do it in your head, and that's fine. But I'm always going to draw it because I like to have the visual, and it doesn't have to be anything fancy, but just knowing in which quadrant it terminates is going to make our life so much easier. Okay, so it's a positive angle, so we are rotating counterclockwise, and 6 pi over 11 is going to fall into which quadrant? So again, remember we're looking at the coefficient. 6/11 is more than half, right? Because 5.5 would be half. So it's greater than pi over 2, but it's not 1 because it's 6/11 is obviously less than 1, right? So we know we're going to have to be somewhere in the second quadrant. Does it matter where? Absolutely not. Who cares? I'm just doing this so that it helps me to see visually where my reference angle is. Okay, so here is my angle. So my reference angle is going to be terminal side and negative x-axis because that is going to give me my acute angle. Now I just need to figure out the measure of that reference angle. Okay, well, I know that this reference angle is this amount short of this whole thing, right? What's the distance or what's the angle measure if I go from here and rotate to here? And again, we're thinking in terms of radians, so don't tell me 180 degrees. So in radians, I know that the measure from here to here is pi, right? And I know that this piece is 6 pi over 11. So how am I going to find the green angle? Well, if you said subtract, you're a genius. So we're just going to take pi and we are going to subtract 6 pi over 11 from that. And that will give us the measure of our reference angle. So what is pi minus 6 pi over 11? This is just 11 pi over 11, right? So this becomes 5 pi over 11. Okay. Something to keep in mind when you're looking for the measure of reference angle. A reference angle we said was acute, right? And we said that an acute angle has to be, the measure has to be between 0 and 90. So what does that tell us about our reference angles? They should always, 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 always be, you guessed it, positive. And so the direction, the rotation doesn't matter at all for the reference angle. The reference angle is just the measure of the angle itself. There's no movement at all with that reference angle. Okay. Let's try another one. How about negative 3 pi over 5? I know it'd be so much easier if I just did them in degrees, right? That wouldn't be as much fun. Okay, so negative 3 pi over 5. Let's think about which quadrant it terminates in. So it's a negative measure. We're going to rotate in this direction. So that means we will end up in which quadrant? We will end up in the third somewhere, right? 3/5 is bigger than half, but less than 1. So it's going to have to be between these two quadrants, or between these two axes, I'm sorry. So it'll be in the third quadrant. So where is our reference angle? Our reference angle will be formed with the terminal side and the left side of the x-axis because that is our acute angle. So we're going to do pretty much similar to what we just did, right? I know this whole angle is pi. And I know that this, again, the negative doesn't matter. That just gives me the direction, right? Is 3 pi over 5. So how am I going to find my reference angle? Well, my reference angle is just pi minus 3 pi over 5, which is 2 pi over 5. Again, is that an acute angle? 2/5 of pi is less than half, so it would have to fall somewhere in that first quadrant, right? And it would in fact be an acute angle. Okay, good with that one? Let's do one more, shall we? We'll do it in degrees just because I feel like I should show you one in degrees. Let's say we had, I don't know, how about 322 degrees? Okay. So if we think about our angle and where it's going to terminate, positive x-axis, we're rotating counterclockwise since it's a positive angle measure. So that will put us somewhere into the fourth quadrant, right? So this angle is 322 degrees. All right, so what is our reference angle? So terminal side of that angle, and this time we're going to choose the positive x-axis since that would form our acute angle. So what is our reference angle then? Okay, so this one, since we terminated in the fourth quadrant, let's think about this. We know that one full revolution would be 360 degrees, right? But we only want the green portion. So if we know the blue is 322, then the green has to be 360 minus the distance we've gone, which would give us, oh, can I subtract 38 degrees? So our reference angle would be 38 degrees. Okay, hope that made sense. As always, we will have Zoom sessions depending on your hour. You can check the schedule on Schoology. And as always, email me anytime if you have questions or are having trouble with any of the material. Have a great day, you guys.